Let's proceed. Let's proceed. Go ahead.
Check the number can be as the product of two equal integers. As the integer multiplied by itself, this can be written using index notation. 3 squared is 3 squared.
Okay.
Square number, a prime number. A square number as an added number or factor. Is it so you said that's it or factor. Confirm that a number is a cube. Check that the number can be expressed as a product of integers. A cube index function. Find working out here.
Okay, so what you're trying to say right now, to confirm that the number is a perfect square, check that the number can be expressed as the product of two equal integers. And that means an integer multiplied by itself. And of course, it can be written using index notation. For example, you can say 3 squared, you can say 4 squared, you can say 2 squared, you can say 5 squared, or 6 squared, as the case may be. So, a square number cannot be a prime number because when it multiplies by itself, it has capacity to replicate it in double fold when you do what's called square root for that same number it produces, right? So to confirm that the number is a cube, what are you going to do? Read out for me. Read out for me. What will you do?
Check that the number can be expressed as a product of 3 equal integers. A cube may be written using index notation.
5 cubed. Okay. So you can see the difference between squared and cube as the first one is squared to its value. That of the cubic value will be multiplied in ratio of index in 3 places, right? So let's follow the working out we have below here. Let's look at example. We have number 1, number 2, number 3, 4, 5, and 6, right? So for the integers 1, 2, 3, 4, 5, and 6, decide whether they are prime, whether they are square, cube, or none of this. Can you do that? The question said 1, 2, 3, 4, 5, and 6. For the integers we have right there on the screen, we have to decide whether they are prime. Which one is prime among the numbers? Which one are square among the number? Which one are cube or none of this in the number? Can you do that? Go ahead. Go ahead. Go ahead if you can.
You have to press next. Okay. So number 1 is it's not squared. Number 2 is not. These are all squared.
You know, we are classifying the number on 4 headings: prime, square, cube, and none of this, right?
Yes. Okay. So number 1 is none of them.
Okay.
Number 2 is a prime.
Number 2 is a prime. You can divide only one on itself.
Yes, sir.
Go ahead.
Number 4 is a square.
You jumped 1. Why did you jump 3?
The prime. And number 6.
Why did you jump 3 before going to 4? You didn't talk about 4. What category do we classify 3?
So I said number 1 is none. Number 2 is a prime. And then I said number 3 is also a prime.
Okay. What's the number 4?
Then number 4 is a square.
Squared of 2. Okay. What's number 5?
Is a prime.
Number 6?
Oh, is number 6 is none of them.
Is none of them. Perfect. That means we have 2 none of them, 3 prime numbers, and we have 1 square. No cube there at all. There's nothing like cube. Okay, let's look at next. Let's look at next. See, just like we explained, 1 has only 1 factor, which is 1. 2 has exactly 2 factor, that makes it prime number. 3 has exactly 2 factor, that makes them prime number. 4 has 3 factors, 4, 2, and 1. 5 has exactly 2 factor, 5 and 1. 6 has 4 factor, 6, 3, 2, and 1. The prime numbers are 2, 3, and 5, just like you rightly said. So that's a perfect explanation and solution to that challenge. Okay, let's go. We have another question here. Can you attempt to this? Okay, they are still explaining. It's still explanation that continues. The explanation continues. Factor 1, 1 times 1, 2 times 1, 3 times 1, 4, 2, and 1. Or 4 is equal to 2 times 2, that's squared. 5 and 1, 6, 3, 2, and 1. So square numbers, 1 square is equal to 1. You know, you didn't get that. You never knew it exists. 1 is actually a squared number. Because when you multiply 1 by 1, it's going to give you 1, right? So we have 2 squared numbers there. That's 1 and 4. We had others that are product of only 2 factor themselves and 1, which are prime numbers. Then that of the 6 is non because it had more multiples of value. Okay, let's go next. Let's go to next. Cube number. We even have cube number there. That's 1. Can you see that? That means 1 is actually a very universal number in that category. As it's acting a square, is acting as a cube also. It's not supposed to be classified under none of the above. Are you there? Are you still there? Are you still there? So, unit is 1. Are you still with me? Good. So, 1 as a factor is a square, is a cube, and 4, of course, factors and also squared. We have units of 1 and the composite number, which is 4 and 6. That's 146. Are you there? Good. So, let's look at what is the product of prime factors. Can you read that for me?
And the factor is circle to show this. If now split into a further part, factor greater than 1. This process until the branches all end in prime number. These are the prime factors of the number. Write the number equal to the factor multiplied together in numeral order. Use index notation when a number occurs more than once. The factor tree of a number can appear different, but the number at the end of the branch and the products or factors will always be the same.
Are you done? Okay. So do you understand exactly what you've read?
Yes, sir.
Okay, that means if yes, the branch does not go any further and the factor is circled to show this. If no, split into a further pair of factors greater than 1. That's are the two major conditions for getting what product of a prime factor is all about. Okay, let's look at this example number 1. Are you with me? We have to write 540 as a product of each prime factor. Do you have idea of this?
Mm, okay, sir. I think I can do it.
Try it. Let's see quickly.
Use 5.4 times 10 to the power of 2.
You say what?
To the power of 2, which is 5.4 times 100.
I didn't hear you clearly.
So,
You say what?
5 times 4.
5 times 4 is 20.
Then, I mean, okay, wait, so I'll just type 5.4, then times 10 to the power of 2.
Write 540 as a product of each prime factors. That's what the question is demanding of us. So because of time,
So, it's not 5 times 4.
that's 54 times 10.
So, I thought you can do research.
You say what?
If you do 5 times 4 times 10 to the power of 2, you still get the mark.
Yeah, that's still correct. That's still correct because that 5 times 2 is 10. I mean, the 5 times 4 is 20. Is still correct. Okay, so let's go to next. Let's look at next condition. This is what you were saying. Apart from the 54 times 10, we have 5 times 2 under 10. We have 6 times 9 under 54. And 6 can give us 2 times 3. Why 9 give us 3 times 3, right? Let's go to next. 540 to 54 and 10 to 6 and 9 to 10 and 2, 5 to 2, 3 and 3, 3. That means starting with the smallest, we have how many 2 there? 2 in 2 places, right? That's this one and this one. Then we have 3, how many places? 1, 2, and 3. These are the 3 of them here. We have 5 only in one place. So 2 square multiplied by 3 square, 3 cube multiplied by 5 will give us 540. It's as simple as that. So example number 2, n is equal to 5 cubed multiplied by 11. Are you there? So what is 5 cubed?
5 cubed is 125.
Okay, you multiply by 11, what will it give you?
2,505.
You say what? Have you confirmed that?
1,070.
125 multiplied by 11. What will it give you exactly?
375.
Are you still there?
Yes, sir.
125 times 11 will give us 1,375. Are you there? So let's start first. First, we got the answer first, 1,375, right?
Yes, sir.
So, how many 5 are here? 5 times 5 times 5 times 11. So, that will be 5 cubed times 11. And the number will be 1,375. Any problem with that?
Yes, sir. No, sir.
No problem with that. Okay? Let's quickly get our quiz on multiples and factor again to replenish our brain. Let's start. Question is already on. Question is already on. Are you there? Don't know how to make it. Don't know about. I'm having class. Don't know. Enoch, are you back? It seems the network tilted you a little bit. So, there's a question on the screen for you to solve. Let's take a quiz on multiple.
Practice. What you have, practice what you have learned about multiples and fractions just quiz. The question needs to be explained. You try to keep testing your knowledge. Which of these so the other one, 200, 260.
200 and what?
260.
260, of course. That's the correct answer. Next question.
64.
64.
Sir.
Are you sure?
Sir.
Number 3.
Uh, 27, sir.
27.
Yes.
Power of 3 is 81. Which of these numbers? See, power of 3. That is 3 times 3 times 3.
27, sir. Because 9 times 3 is 27.
No. It's like you don't understand the question. which of these numbers is a power of 3 and a square number? Power of 3 is 3 square, which is 9, right? Then 9 square is 81.
Oh.
That's just what they meant. Actually, the question is a little bit technical. But notwithstanding, let's go to the next question. Let's go to the next question.
Uh, 125, sir.
Okay, that's straightforward. Next question.
So would it be 41? Wait, 41.
Work out 3 square plus 2 raised to the power of 5. That's 9 plus 32. What will you get? That's 41. Add 41. Wow, 4 over 5, okay? Not bad. Not bad. Not going to higher value. That's not for you. So, at this juncture, we can boldly say that we've done revision on what we call factors, multiples. Are you there? We've done factor, we've done multiple, we've done factor pair, and many others. So, let's go back our curriculum document. Okay, let's look at decimal calculation. That's the next to talk about. Decimal calculation. Decimal calculations. Yeah, I'm with you. I am still with you. We want to look at decimal calculation. And we have 4 basic headings here. The first is place value and ordering decimals. We have how to add and subtract decimals. We have how to multiply decimals. And finally, how to divide decimals. Are they not simple? 4 major headings we are going to look at. Let's start with the place value and ordering of this decimal. So what are going to be our key points today? What are going to be our key points from this class?
Each digit of a number has a place value. In the decimal system, the place value of all powers of 10, including hundreds, 10 units, tenths, 100 tenths, and thousands. In every number, each place to the left is 10 times greater, and each place to the right is 10 times smaller. The decimal point separates the whole number from the part or fraction of a number. An understanding of a place value is essential for ordering decimals. Understanding place values. A place value can help to clearly show the value of each digit. To find the place value of a digit, write the number in a place value using the decimal point to get each digit in the correct column. Read the column for a place value of the digit. The value of the digit is a digit multiplier by the column heading. Two decimal numbers can be compared in size using inequality symbols or dash. Decimal numbers can be arranged in ascending or descending orders.
Okay.
45.
So a simple example is written right here on the screen. We're having 352.71, and we asked to state what place value is 5 in that particular arranging order. So what place value is 5? Enoch,
Hello, sir.
what place value is 5 as shown on the screen?
5 is the tenths.
That's
I mean,
tenths.
10.
That's 10, not tenth. 10 because it's tenths, because it's the one next to unit before you now go to tenth and hundredth, right? So we have hundred, we have tenths, we have units, then we have tenth, and we have hundredths, right? So this place of 5 actually is actually tenths, as simple as that. So 5 times 10 will now give us what? 50. That's the actual value of that. Example number 2. What's the place value of 9 in that decimal value on the screen?
So 9 would be the hundredths.
Hundredth. Yeah, that's correct. That's hundredth. That 1 over 100 after 1 over 10 and after the unit. So 9 times 100 is 0.09. And that's what the value is as far as that is concerned. Let's go to ordering of decimal quickly. Can you go ahead?
To compare a list of decimals, write the number in a column. Write the number in a place value table. Line up the decimal points to each digit in the correct column. If the number has a different amount of digits, then repeat some gaps in the column. Fill any gaps in the zero. Starting at the left from the greatest place value. A greater digit means that the number is greater. When digits are equal in a column, move to the next column to the right and compare the digits. Through practice, this can be done without the place value table by writing the numbers lined up with the decimal points. The decimal point of a whole number comes after the last digit. Once each number is compared, they can be put in ascending or descending order.
Okay, so having gotten that explanation, number 3 say compare the digits in the columns starting at the left with the greatest place value. Then you move to the right, right? So we have example 1 right here. I see 4.08, 14.101, 4.062, and 4.1. We say this smallest to the greatest in ascending order. In what? Ascending order. Let's look at 4.08, 14.101, 4.062, and 1.1. This is how to arrange it first. Then number 2, you now add zeros to all. When 0 is added to the front, and to the back, it normalizes what it ought to be. Are you there? We added those zero at the front and at the back for a simple reason. And what is the reason? As explained, we have aligned our number to know where the highest value starts and stops. So, can you see? That means the highest is 14.101, right? Okay. Why is it? Because under tens, there's one. There's only that one that has one, so it's the highest. Now that everything is 4 under this place, let's move to this. All are equal at this level. So we move to, we say we should take it from the left to the right, right? Whichever number comes first is the highest as defined. You take it from the left to the right. And initially it's only one that qualifies 14.1 to be the highest. Now all of them are 4. Let's move to the right again. We have 1, 1. And 14 is already gone. So the next is 4.1, right? Are you still following? We are taking to the right. And now 4.1 is the next. We'll now move again. And you see that 8 is bigger than 6. So the next is 4.08. Then we'll move to the right. And we have the final one. So 4.062 is the least among all of them. And that's what the explanation is all about. That's what the explanation is all about. Okay. Question is here. What are the values of the digit? Enoch, are you okay?
Yes, sir.
What are the values of the digit 8 and 5 in the number 826.735?
So would it be, so 5 would be the 5 would be the thousands, then 8 would be the hundreds.
Okay. Let's look at it together. Okay. Thousands and hundred. That's simple, straightforward. No hanky-panky. Let's quickly practice place value and ordering decimal right here. Are you ready?
Sir.
Okay, let's go. Ordering activity. Put these decimals in ascending order.
Okay, sir. So, so from the highest to the biggest number, right?
We are going to do it highest from up down because it's ascending as it goes up. The highest will be up, the lowest will be down.
5.34 would be at the top.
5.34 will be at the top. So let's move it.
And then 5.304.
Next, okay.
And then 5.2 will exchange with 5.218.
You see what?
5.2. Yes, sir. So it's been like this. Yes, like that.
Okay, this is how it's supposed to be. Okay. You see? You see where your error come from? This is bigger than this. Okay, so it's 5.2, 5.21, 5.22, 5.304. Okay, you see that? Ascending order. Okay, probably. Probably the arrangement is the other way around. Everything selected as good. It's just that we turn it upside down. Do you understand that?
Yes, sir.
It was turned upside down. That's why it is like that. Place value and ordinary decimal. Next question, are you there?
Yes, sir. With this one, the free is free. Number 3, sir.
Number 3. Okay, that's correct. Let's go to the next question.
This one would be the 700s.
700, that's correct. Let's go to the next question. Which of these numbers is greatest? Are you still with me?
Sir.
Which number is the greatest?
Is it 27.4?
Yeah, that's the greatest there. There's no hanky panky about that. So, next question is here.
This one would be, so it will go, it'll go less than.
You say what?
So it would be, no, it would be the third one, number 3.
This? That's correct, of course. Because when you move from the left to the right, when you get to that 2 and 4, 4 is higher than 2, right? Next question on the screen. Next question on the screen. Is it not still on board?
0.771.
Which number is the greatest? Say 0.1?
0.71.
Perfect. Perfect. That's very correct because when you move from from the left to the right, that's where the 5 is after the 7 must have been cancelled. The rest are 0. So let's go to the next question.
Hello, sir.
I'm with you. Which three of these statements are true?
A, B, and D. A, B, D.
A, B, D, right? Okay. A, B. I don't understand these people. Okay. I will select only the ABD. Oh my God. That's mouse error. You got it right, actually. That issue is from the mouse. Okay, so at this juncture, we are done with all the quizzes. We have spent 2 hours here. This is exactly 9 o'clock p.m. And I want to sincerely appreciate you for your proactive, interactive class today. I want to appreciate you for staying focused throughout the classes. You were not distracted, though the network's a little bit distractive, but we have power over all odds, and we're able to have successful class on this mathematics preparation class for your assessment. I want to believe this revision makes sense to you, right? So, how do you feel? What do you have to say? Have you been able to capture the area of those subtopics? Okay, that means you go with we are good with the lesson. Perfect. So, of course, you know that meeting point remains London in UK time is the same thing with Nigeria right now. So 7 o'clock in Nigeria is the 7 o'clock in your place where you are in London. And of course,
Yes, sir.
we are maintaining 2 hours, that's 7 p.m. to 9 p.m. The moment there's a swap of time in London, do remember to let me know so that I can adjust my time immediately, right? And the days of the lesson, of course, it remain Tuesday, Wednesday, Saturday, and Sunday. The moment your exam is over, we swap to only Saturday and Sunday, right? So, I want to say pleasant night rest to you today. See you by Saturday. Hello, are you there?
Yes, I'm there.
Our class on Saturday is 12 p.m., 12 noon. Hope you will set alarm, you will set your calendar for that task. Is Enoch still there?
Yes, sir.
See you by Saturday, 12 p.m. at noon time.
Okay, sir.
Good night.